Okay, let's work for a little bit on consecutive integers. Consecutive means one right after another. So if I were to say that Babe Ruth hit 4 consecutive home runs, it means that he hit one home run after another with nothing in between. Well, that's the same way to work with consecutive numbers. So a consecutive number would be numbers like 1, 2, 3, 4, or 6, 7, 8, 9. You get the picture. These are all consecutive. Okay. Now, if we want to look for consecutive integers, but we don't know where we start, remember what we talked about in the last video, and that is anytime I don't know something, I start with a variable. Now, to kind of distinguish this section from other sections, I'm going to make that variable n. So n is what we don't know. So this is our unknown starting point. Okay, starting point. Now, that may be, n may be 10, it may be 20, it may be 450. We don't know what it is, but we do know that it is the starting point, just like 1 is the starting point up here. So what I want you to notice is this. If I were to go from 1 to 2 here, I would have to add 1 to get from 1 to 2. And then if I were to go from 1 to 3, I would have to add 2. And then if I were to go to 1 to 4, I would add 3, right? So this is what's going to build our formula for my consecutive integers. Anytime I need to know a sum of consecutive integers, what I'm going to end up doing is I'm going to use the starting point, and then each consecutive integer is going to get its own summation that's going to get me the next number in the line. For example, if I have 3 consecutive integers, then that would look like the first consecutive integer is n, the second would be n plus 1, the third would be n plus 2. Because if this were, say, 10, I'd have 10, 10 plus 1 is 11, 10 plus 2 is 12. So that's going to give me 10, 11, 12 consecutive integers. Okay? Okay, so let's do a problem. So the sum of 2 consecutive integers is 63. Well, remember, sum means addition. And we know we're looking for 2 consecutive integers. Well, remember, consecutive is n plus 1, n plus 2, n plus 3, etc. as far as we need to go. We only need 2. So remember, our n is our starting point, and more than anything, that is also our beginning variable. So there's our first number, n. The second number, because we want 2, is going to be n plus 1, because I just want one number up the line. I'm dealing with the sum, so I need addition. So the sum is 63. So that's going to be the first integer plus the second integer is equal to 63. And I've translated that. But now we need to find the 2 integers. Well, we can do that just by solving. So n plus n, combining like terms, is going to give me 2n plus 1 is equal to 63. Now we can solve. So I'll subtract 1 from both sides. That's going to give me 2n is equal to 62. That's a good number. That's a good sign because I'm dividing by 2. I want that to be a whole number when I do the division. It's going to happen that way. So then we need to divide by 2, which is going to leave me, these are going to cancel, it's going to leave me that n is equal to 31. Well, that tells me what n is, but remember, I need 2 integers. So I need to know what the first integer is. We know that that's n. But then we need to know what that second integer is, and that second integer is n plus 1. So all we have to do is plug in my 31 into this equation, So n plus 1 is 31 plus 1, gives me my second integer of 32. Now, is that important for this problem? No. You know that the next consecutive integer up from 31 is 32. But sometimes it gets a little more difficult when you're dealing with negative numbers, so it's always a good idea to kind of plug that in to determine that you're getting the right thing. Another beauty about this section is I can always just add 31 and 32. That's going to give me 63, and we know that we've got the right answer. Okay, so we did a sum of 2 consecutive. Now we need to do a sum of 3 consecutive. Again, we don't know what the number we're starting with is, but we do know that we need 3 numbers. We know that they're consecutive, so there's only 1 in between them. So what we're looking for, again, we need to start with our n. That's the starting point. And then we need a second number. Well, that's simply n plus 1. That's the second number in our sequence. And then we're going to need n plus 2. Oh, I made a mistake. This should have been n plus 1, not n plus 2. n plus 1. Okay, so there's the first number, the second number, n plus 1, the third number, n plus 2. And then the sum of those 3 is going to get me 59. So that's going to equal 159. And I'm dealing with the sum, so I want to add all of these numbers together. Now, now we can just do solving. So n plus n plus n, well, that's going to give me 3 n's. 1 plus 2 is going to give me 3. And then I get what equals 159. Well, solving this linear equation, I've got to subtract my 3. And then I'm going to get 3n is equal to 159 minus 3. That's going to be 156. Dividing by 3. 3 will divide into 15 evenly 5 times. 3 will divide 6 2 times, so I know that my n is equal to 52. But I don't want just one of the numbers, I want 3 of the numbers. So now I need to go in and find out what my n plus 1 is. Well, n plus 1 is going to be 52 plus 1, which is going to give me 53. And then I'm going to have n plus 2. So n plus 2, adding those together, that's going to be 52 plus 2 is going to give me 54. And again, 2, 3, 4, that's consecutive integers. Again, you can plug these back in to check your answer if you want to.